Assalamu alaikum everyone. I am Mahfuj Hasan and today I will be presenting on AWS Cloud Deployment Architectures. While the cloud offers hundreds of services, successful deployment relies on a solid foundation. In this session, we are going to focus specifically on three critical pillars of modern architecture: domain management, container orchestration using ECS and EKS, and managed database solution with RDS. To understand how these advanced services work, we need to view our architecture as a construction plan. We will build this up in layers. First, we will briefly touch on the network foundation. We will look at structure of compute. Then we will dive deep into modern assembly using container orchestration. We will examine the data core using RDS, and finally we will manage our domain using public address system Route 53. Layer 1: establishing your private cloud foundation with VPC. A virtual private cloud or VPC is a logically isolated section of AWS Cloud where you can launch resource in a virtual network that you defined. Subnets. Subnets are the segment of VPC's IP address range where you can place group of isolated resources. Route tables, a set of rules that determine where network traffic from your subnet is directed. Internet gateway, a gateway you attach to your VPC to enable communication between resources in your VPC and internet. Security groups, a virtual firewall for your instance to control inbound and outbound traffic at the instance level. Network ACLs, an optional layer of security for your VPC that acts as a firewall for controlling traffic in and out of one or more subnets. Layer 2: choosing the right engine for your code. Compute services are the engines that run your application code. AWS provides a spectrum of options, from full control over virtual servers to fully managed serverless execution. AWS EC2. These are the virtual machines in the cloud, the IaaS model offering maximum control. AWS Elastic Beanstalk, a managed service for deploying and scaling web application. The PaaS model, abstracting away the underlying infrastructure. AWS Lambda, a serverless compute service that runs your code in response to events. The FaaS model, where you can only manage your code. EC2 versus Elastic Beanstalk versus Lambda. EC2 is a secure, resizable compute capacity in the cloud. It offers full control over OS, networking, and software stack, ideal for legacy application and complex custom environments. It used when you need root access, a specific OS, or persistent long-running servers. Elastic Beanstalk is an orchestration service that handles deployment, capacity provisioning, load balancing, and scaling. It is the fastest way to deploy standard web application, reduce management overhead while retaining some configuration control. It is used when you are deploying a standard web app and want to focus on code, not infrastructure. Lambda. Lambda is a event-driven serverless compute service. Execute code without provisioning or managing servers. It offers pay only for the compute time you consume, automatic scaling, no server management. It is used for event-driven tasks, APIs, data processing backends, or short-running stateless functions. Selecting the right storage for your data. Not all data is the same. AWS provides specialized storage service optimized for different access patterns and data types. S3 object storage. Stores data as object in buckets. Infinitely scalable, ideal for unstructured data like images, videos, backups, and static website assets. EBS, block storage. Provide persistent block storage volume for use with EC2 instance, behaves like a virtual hard drive for your server. EFS, file storage. A fully managed elastic file system for use with AWS Cloud Service and on-premises resources. Ideal for shared access across multiple EC2 instances. S3 versus EBS versus EFS. S3 is a highly durable and available service for storing and retrieving any amount of data. It offers unmatched scalability, durability, and cost effectiveness for unstructured data. It is used for website assets, data backups and archives, big data analytics, static website hosting. EBS, block storage. It is a high performance persistent block level storage volume for EC2. It provides the low latency performance required for operating systems and databases running on EC2 instance. It used in the case of boot volume for EC2 instance, transactional and NoSQL databases, throughput instance application. EFS, file storage, a simple, scalable, elastic file system. It provides a shared POSIX compliant file system that can be accessed by thousands of EC2 instances concurrently. It is used for shared content management systems, web service farms, home directories, big data, and analytics workloads requiring a shared file systems. Layer 3, modern assembly with containers. Containers package an application's code with all its dependencies into a single portable unit. Orchestrator manages the lifecycle of these containers at scale. ECS, Elastic Container Service, a highly scalable, high performance container orchestration service that supports Docker containers. It is deeply integrated AWS opinionated solutions. EKS, Elastic Kubernetes Service, a managed service that makes it easy to run Kubernetes on AWS without needing to install and operate your own Kubernetes control plane. It provides open source compatibility. ECS versus EKS. ECS, a fully managed container orchestration service from AWS. Key aspect, simplicity and deep AWS integration. It is easier to set up and learn with seamless integration with others. AWS service like IAM, VPC, and Route 53. It is best for teams that are all in one the AWS ecosystem and preferred simpler, more managed experience for running Docker containers, ideal for deploying microservice application. EKS, a managed service for running and scaling Kubernetes on AWS. Key aspect, power and portability, provides the full power of the open source Kubernetes API, enabling hybrid cloud strategies and use of the vast Kubernetes ecosystem. Best for teams with existing Kubernetes experience, those running complex multi-container apps, or organizations that require a portable open source standard. The Fargate versus EC2 launch type. When running containers on ECS or EKS, you must choose how the underlying compute is provisioned. EC2 launch type. Here you run your containers on a cluster of EC2 instances that you manage. You have granular control over the instance type, patching, scaling, and security of the underlying EC2 fleet. Here you have to pay for EC2 instance regardless of whether they are running containers. It is best for workloads with predictable resource need or that requires a specific EC2 instance configuration. Fargate launch type. It is a serverless compute for containers. AWS provisions, manages, and scales the underlying infrastructure automatically. Here you don't see or manage any servers. You just define your application, package it in a containers, and specify CPU or memory needs. The pricings are per container based on the vCPU and memory resource it requests per second. It is best for most applications, ideal for bursting workloads, microservices, and focusing on application development instead of infrastructure management. Layer 4, the data core with Amazon RDS. Amazon Relational Database Service or RDS is a managed service that makes it easy to set up, operate, and scale a relational database in the cloud. Key features: manage maintenance. AWS handles patching, backups, and failure detection. Automated backups. Point in the time recovery and automated snapshots. High availability replication. Easily create read replicas and multi-agent deployments for disaster recovery. Scalability. Scale compute and storage resource with minimal downtime. Supported engines are MySQL, PostgreSQL, MariaDB, Oracle, and SQL Server. Layer 5, the public address with DNS and Route 53. Domain name system. DNS is the phone book of the internet. It translates human-friendly domain names like google.com into machine-readable IP address like 8.8.8.8. The key DNS records types are A, MX, NS, CNAME, and TXT. Amazon Route 53, a highly available and scalable cloud DNS web service. It connects user requests to infrastructure running in AWS and can also be used in the Elastic IP. So what does this look like when we put it all together? Here is a real-world microservice architecture. The user enters an URL, Route 53 resolves that to an IP address. Then the request enters our VPC through the internet gateway and hits an application load balancer. Then the traffic is distributed to our container cluster across private subnets. These services connected securely to our RDS database in a separate database subnet. And finally, static assets are retrieved from the S3 bucket. To wrap up, if you follow this blueprint, you are adhering the three key principles. 1. Isolated and secure. We use private subnets for our core resource. 2. Choose your right tool. We selected the right compute and storage for the specific job. 3. Automate and abstract. We leveraged managed service like RDS and forget to reduce our operational burden. By following this blueprint, you can focus your time on building features, not just managing infrastructure. Thank you everyone for joining with me. If you have any question, please feel free to ask in the comment box.